Imagine you've just written the most elegant, highly optimized database query of your entire career. Like, it joins 5 massive tables, it sidesteps an n+1 problem beautifully, and, it executes in absolute milliseconds.
Oh, the dream scenario for any back-end engineer.
Right. It is the dream. So you hit run, but when it spits the output into your terminal, it's just this massive, unformatted, completely unreadable wall of comma-separated text.
Yeah, so the underlying logic is flawless, obviously.
Hmm?
But because of the presentation, the data itself is, well, it's practically useless.
Exactly. You've basically built this brilliant high-performance engine, but you've wrapped it in a chassis that no one can actually drive.
Which is incredibly frustrating.
It really is. And, if you are listening to this right now, you are likely a senior back-end engineer. You live and breathe logic, system performance, scalability, architecture, all of that.
But maybe not so much the front-end stuff.
Right. So our mission today for this deep dive is to basically translate those front-end dark arts into that exact back-end logic you already know. We are unpacking Chapter 2 of Web Design for Back-end Engineers.
And we are expanding your toolkit today with 3 incredibly concrete, highly logical tools. We're talking about alignment, proximity, and contrast.
Yes. And before we jump into those, let's just set the baseline right away because, you're already familiar with the foundational concepts from Chapter 1, right?
Yeah, so we aren't going to spend time re-explaining visual hierarchy or like the squint test today. We know you are already using white space to give your layouts room to breathe.
And we know you are religiously applying the bevel-it rule. You have those fundamentals completely locked down.
Totally. So let's pick up exactly where that leaves off. We know white space gives a layout room to breathe, right?
Yeah. But, a giant empty room is really just a void until you actually arrange the furniture in it. We need to establish order within that empty space.
Right, and the primary mechanism for establishing that order is alignment.
Okay, so let's talk about alignment, because the book uses this analogy that I absolutely love.
The visual linter analogy.
Yes! That alignment is the visual equivalent of a code linter.
It's such a perfect comparison.
Yeah.
Think about why you run something like Prettier or ESLint in your code base in the first place.
Right, because if one function has a 2-space indent, and the next one has a 4-space indent, and then another one has trailing white spaces and random line breaks.
The compiler genuinely does not care.
Right.
The machine reads it just fine. It executes perfectly.
But to a human engineer reading that file, it creates this massive cognitive friction. You end up burning all this mental energy just parsing the formatting instead of actually tracing the logic.
Exactly. And if the formatting is that careless, you instinctively assume the underlying architecture is careless too. It degrades your trust in the code.
It totally degrades trust. And that is the exact psychological response that users have to unaligned visual design.
Yeah, when elements on a page are strictly aligned to a common edge, the page just feels intentional. It feels trustworthy.
But when a submit button is just, 3 pixels wider than the input field sitting right above it.
Oh man, the layout fails that visual linting process in the user's brain. They might not consciously identify, like, oh, that's a 3-pixel difference, but the page just feels sloppy.
It just feels off.
Yeah.
So let's break down the mechanics of how we actually apply this linter, starting with left alignment. Why is left alignment the absolute default for body text and form layouts?
Well, it really comes down to biological eye movement.
Yeah.
Because in Western languages, we read left to right, top to bottom.
Right.
So left alignment provides this hard, predictable, vertical anchor. When your eye finishes reading a line of text, it naturally sweeps back to the left.
And because of that left alignment, it knows exactly where the next line is going to start.
Exactly. It is the path of least resistance for the human eye.
Okay. But then we have right alignment. And if I look at how right alignment is actually used in the wild, it seems, incredibly specialized.
Oh, it is highly specialized. You primarily use it for numerical data, like in tables.
Oh, right. Because of the decimal points?
Yeah. If you have a column of currency values and you left align them, the decimal points just scatter everywhere based on how many digits there are.
So you can't quickly scan down the list to compare the magnitudes.
Right. But if you right align them, the decimal points stack perfectly. You occasionally see it in secondary navigation too, like throwing a log out button to the far right of a header.
Yeah, that makes sense.
But otherwise, you keep right alignment locked away. It's not for general use.
Okay, wait. I have to challenge this whole strict alignment framework when it comes to center alignment.
Uh-oh. Okay, let's hear it.
Because if I'm building something like a login modal, centering the title, the username input, the password input, and the submit button, it creates this perfect symmetrical column.
Sure.
It feels mathematically balanced, It feels really safe to an engineer. So why is centering considered such a massive failure for longer layouts?
Okay, so you are hitting on a really crucial distinction here. Micro layouts versus long-form content. A login modal is a micro layout. Center alignment works beautifully for a short heading or a quick stack of 3 elements. It acts like a cohesive little badge.
Right.
But the moment you try to center align a whole paragraph of text, you completely destroy that predictable anchor we just talked about. You create what typographers call a ragged edge on both the left and the right sides.
Because every single line of text has a slightly different character count.
Exactly. So the physical starting point of every single line shifts dynamically.
Oh, wow.
Yeah. When a user's eye finishes reading line 1 and sweeps back to start line 2, the starting point has physically moved.
Right.
So their eye has to perform these tiny, rapid movements called saccades. They're basically actively hunting for the beginning of the next sentence.
And that requires micro adjustments that dramatically increase cognitive load.
Yes. It's exhausting to read.
It's like trying to read a Python script where the indentation level just changes randomly on every single line.
Oh, that sounds awful.
You would completely lose your mind trying to trace the scope of the functions.
But that is exactly what your brain is experiencing visually with centered body text.
So the golden rule to take away here is really about minimizing invisible lines. Every single element on your page must align to something else.
Nothing should ever just float arbitrarily. Never.
Right. If you imagine drawing invisible vertical and horizontal lines through your layout, every element should snap firmly to one of them.
And if you have to draw like 20 different vertical lines to hit the edges of all your various UI components.
And your design isn't aligned. It's just chaotic.
Exactly.
Okay, so our invisible linter is keeping our edges perfectly clean. But if everything is just neatly snapped to a left edge, it just looks like one massive, unbroken column of data.
Right, which is his own problem.
Yeah. How does the user instantly know where one database record ends and the next one begins without us having to draw literal border boxes around every single thing?
And that's where distance does the heavy lifting. Which brings us to our second tool for the day, proximity.
Proximity.
Yeah. So if alignment is about establishing order, proximity is about defining relationships. And the rule here taps directly into Gestalt psychology.
Okay, Gestalt psychology. Break that down for us.
It's pretty simple in practice. Elements placed close together are perceived by the human brain as being related. Elements placed far apart are perceived as unrelated.
And this operates on a purely evolutionary level, doesn't it? Like, long before we are parsing text or interpreting UI labels, our brains are grouping shapes based on physical distance.
Oh, absolutely. It's an ancient survival mechanism. Your brain evolved to instantly recognize a cluster of shapes as a single bush of berries.
Or like a tight grouping of shadows as a predator in the brush.
Right, exactly. And it does that without having to analyze every single leaf or patch of fur individually. It identifies the group first and then processes the meaning.
So in a user interface, proximity triggers that exact same pattern recognition instantly without adding any extra UI clutter.
Yes. So we don't need heavy dividing lines or distinct background colors to say these things belong together. We just use space.
And for a backend engineer, if this maps perfectly to how we structure code. This is basically module grouping for the eye.
It's the exact same muscle memory. Think about it. When you write code, you don't just dump every single function into one unorganized megafile.
God, no. You group related functions in a specific module. Or inside a struct or a class, you put related fields right next to each other.
Exactly. Or even inside a single function. You initialize your variables, you hit return to create a blank line, you run your loop, you hit return to create another blank line, and then you return your result.
We are already using physical proximity to visually group logical blocks of execution. We do it all day.
Right. Now you just need to apply that exact same instinct to the visual layout.
So take a standard settings form. A text label and its input field have a tightly coupled relationship.
They're the struct fields, basically.
Yeah, so they must be physically close. But let's say that form has a personal information section and then a billing details section.
Then there must be noticeably more space between those two major sections than there is between the individual inputs inside them.
Because that differential in spacing is what actually creates the visual grouping.
Exactly. The difference is the key.
Man, I have to admit, I am definitely guilty of falling into a trap here, and I know I'm not alone in this.
Oh, let me guess. The equal spacing trap.
The equal spacing trap. Because engineers, we just love mathematical symmetry. We love tools like Flexbox.
Flexbox makes it so easy.
Too easy. It is so tempting to just set a container to justify content, space between, or apply a universal gap. 24px to every single element on the page.
Yeah, it feels fair, right? It feels perfectly responsive.
It does. But this actually completely breaks the user experience, doesn't it?
It really does, because mathematical symmetry destroys relationships. By evenly spacing everything, you are visually communicating to the user that every single element is equally related to every other element on the page.
And in a functional application, that is almost never true.
Never.
Let's visualize how bad this actually gets in that form example. Imagine we have a label called email address, an input box below it, then another label called password, and an input box below that.
Okay, pretty standard form.
Right. But if I just apply a universal 24-pixel gap everywhere,
Then the distance from the bottom of the email address input box to the password label below it is exactly 24 pixels.
right?
And the distance from the password label to its own input box is also exactly 24 pixels.
So it basically creates a sandwich.
Yeah.
The password label is just floating dead in the center of two identical input boxes.
The label is perfectly equidistant, so the user's eye scans down, hits the word password, and on a primal subconscious level, their brain cannot tell which input that label actually belongs to.
Wait, did they type the password in the box above the word or below it?
Exactly. It creates a split second of ambiguity, and ambiguity is the absolute enemy of usable design.
But if you simply tighten the space between the label and its input to, say, 8 pixels,
And then expand the space between the different form groups to 48 pixels.
the ambiguity vanishes instantly. Your brain groups them before you even consciously read the words.
It's basically magic, but it's just logic.
Okay, so proximity groups are elements logically. We know what belongs to what. But when we look inside one of those groups, how do we establish who is actually in charge?
Right, the hierarchy.
Yeah, how do we declare that this specific string is the primary data and this other string is just metadata?
Well, that requires hierarchy, like you said. And the primary mechanism for enforcing that hierarchy is our third tool. Contrast.
Contrast.
Yes, contrast is simply the deliberate difference between elements. And it operates across several dimensions.
Like what?
Well, size, obviously, like making a header much larger than body text.
Yeah.
Color, using a vibrant primary tone for your main call to action button while the secondary button is muted.
Right.
Weight, using a bold font for a key metric, while the label underneath it is a very light font. And shape, putting a circular floating action button over a grid of rectangular cards.
See, here is where I struggle and where I think a lot of back-end logic gets tangled up when we try to do front-end.
What's the struggle?
I have this real fear of making things look comically huge or visually overwhelming. So I'll use like a 14-pixel font for the body text, and then for the subheader, I'll bump it to 15 pixels. Or instead of making something truly bold, I just bump the font weight from 400 to 500.
The subtle adjustments.
Yeah. I try to make these really subtle micro adjustments because bumping it to 24 pixels just feels like it's screaming at the user.
And that fear of the comically large font is exactly what drags engineers into what we call the ambiguous middle.
The ambiguous middle.
Yeah. You are applying a back-end micro-optimization mindset to front-end design. You are used to, tweaking a cache TTL by a few milliseconds or shaving bytes off a JSON payload.
Right, because small changes matter there.
You are comfortable with invisible incremental changes. But the human eye isn't a performance profiler.
It doesn't parse a 1-pixel font difference as a hierarchy change.
It doesn't parse it as deliberate at all. When the human brain sees a 14-pixel font right next to a 15-pixel font, or a light gray border next to a slightly lighter gray background,
It just looks wrong.
it triggers an error-checking response. The brain literally thinks, is my monitor calibrated wrong?
No.
Did the browser fail to render this correctly? Did the developer accidentally apply two conflicting CSS classes?
Oh, wow. It looks like a rendering bug, not a design choice.
Exactly. It causes the user to hesitate,
Which is exactly what we want to avoid.
which is why contrast must be significant. It is governed by the rule of sameness or difference.
Sameness or difference.
Yes.
Okay.
If two elements serve different purposes, you must make them, obviously, unmistakably different. But if they serve the same purpose, they must be perfectly the same.
Man, contrast in design is literally Boolean logic.
It really is.
It evaluates to true, like these things are completely different, or it evaluates to false. These things are absolutely identical.
Yes.
There is no fuzzy logic. There is no kind of similar, but a little bit bigger.
Boolean design. I absolutely love that framework. You have to commit to the true. If you want a heading to stand out from 16-pixel body text, do not bump it to 18 pixels.
You bump it to 24 or 32 pixels?
Make it bold. Change its color. Combine those dimensions of contrast so the hierarchy is undeniable.
And conversely, if something is secondary metadata like, say, a timestamp on a log entry, don't just make it dark gray.
Right, drop the font size down to 12 pixels, make it a significantly lighter gray, and actively push it out of the primary visual flow.
Commit to the difference. I love that. So to kind of synthesize this all into our back-end tool chain today, let's hear the summary. Alignment is your strict visual linter, right? It's minimizing invisible lines and ensuring every element snaps to a predictable grid to eliminate that cognitive friction.
Perfect.
Proximity is your module and struct grouping. It's leveraging evolutionary Gestalt psychology to visually declare relationships using physical distance and completely abandoning the equal spacing trap.
Say goodbye to the equal spacing trap forever.
And contrast is your strict Boolean styling, committing boldly to true difference or perfect sameness without ever getting paralyzed by that micro-optimized fuzzy logic.
Honestly, mastering just these three logical tools, alignment, proximity, and contrast, layered on top of the white space foundations you already know.
That changes everything.
It really gives you the exact mechanics needed to build incredibly intuitive interfaces.
And it sets the stage perfectly for Chapter 3, which we will dive into next time.
Oh, I'm excited for Chapter 3.
Me too. We'll cover the sixth and final core principle, consistency, and then we're going to do something highly practical.
Yes.
We're going to run a complete design audit on a messy, realistic settings dashboard, transforming it from a clunky prototype into a professional interface using exclusively these foundational rules.
And just to reassure you guys, we are still deliberately avoiding the deep weeds.
Oh, definitely.
We aren't touching typography scales, advanced color theory, layout systems, UI components, UX, design systems, accessibility standards, or responsive design yet.
None of that tooling stuff either. We are keeping it purely structural for now.
Absolutely.
I cannot wait for that audit. But before we wrap up today, I want to leave you with a final thought experiment to mull over.
Okay, let's hear it.
We've been talking about applying these rules to the interfaces you build, right?
Mm-hmm.
But think about the interfaces you consume.
Oh, interesting.
Think about the last time you were reading a really confusing, incredibly frustrating piece of API documentation. Maybe you were integrating Stripe or AWS, and you just could not follow the parameter requirements.
We always immediately assume the technical writer just failed to explain the concepts clearly.
Right. We blame the explanations, we blame the pros, but next time you hit a wall with API docs, look closer at the layout itself.
Oh, I see where you're going.
Ask yourself, is the text actually confusing, or is the page just failing the tests of proximity and alignment?
Or are the code snippets physically floating too far away from their explanations?
Exactly. Are the parameter definitions equally spaced in a massive flexbox column so your brain literally can't tell which description belongs to which variable?
The structural presentation is failing the logic.
You might just realize that those bad code docs aren't a writing problem at all. They are just a design bug disguised as a logic bug.
Wow, that's so true.
Fix the alignment, fix the proximity, enforce the contrast, and suddenly the complex logic becomes perfectly clear. Something to think about next time you sit down to write a readem. We'll see you in the next deep dive.